In addition to this complexity of accuracy, of precision versus scalability, another big issue that happens with AI systems, with agentic AI systems, is that there can often be a lengthy cascade. You mentioned earlier this idea of tool calling. So you could have kind of you could have an AI agent that is kind of triaging the call, that is figuring out, okay, based on the conversation so far, it seems like I'm going to need to call tool A, and then maybe later in the conversation they need to call tool B, or maybe tool A, in order to do its job effectively, needs to call on tool C. And so that was a bit of a vague example, but it was to kind of illustrate that you can end up with this cascade of multiple agents in a sequence, potentially making requests in parallel, or having multiple things happen sequentially, multiple calls happen sequentially, all in parallel. And AI agents are responsible for all of that without a human in the loop. So in that kind of scenario, even a small error, especially early on, like what if the triaging agent right at the beginning got it wrong? It called tool A and it should have called tool D.
Totally.
Um, so that can lead to a butterfly effect where one small error in an earlier step can lead to a massively wrong output later on in the conversation. So, what strategies can we employ to mitigate this kind of butterfly effect? And how do you ensure graceful failure when these errors do happen?
Totally. I think this is one of the reasons why evaluation of agents and multi-step evaluations is so different than evaluations of LLMs or any call where you have some input and some output, because not only do you have the non-determinism of a single call, you have the non-determinism and all of the possible pathways through these cascading failure points that just explode in terms of the possible pathways and the possible types of failures. There's also an interesting case where it goes off track, but then the agent saves it. It realizes that it made the wrong mistake, which kind of leads me to, I think, a lot of the pathways. Though a lot of the ways people have been solving this is kind of self-healing agents, where some interesting things I've seen is having an agent in the background for a voice where you have a cheaper and faster, low latency model coming up with responses, but then you kind of have an overthinker in the background that's looking at the whole conversation, and maybe it takes longer to make that call, but the latency is okay as long as it's in the background, and can help prompt the agent to get it back on track, to saying you messed up this order, or you forgot to ask something. You can also employ other strategies for graceful failures around having multiple, redundancy in your systems. I think there's a lot to learn from aerospace and self-driving here as well, where you I think self-driving has really mastered graceful failures, where it has fallback mechanisms. There are ways that it can pull over, or it can ask questions to rider assistants. Um, there's all sorts of systems in place so that it's not just reliant on any one system within the voice agent or within the agent at play. I think how this translates to voice agents is, can you determine when can the voice agent self-determine when the request is too complex for itself? This is already happening a lot today. I would say the majority of our customers already have the ability to transfer to a human when they determine that the task is
Mm.
too complex for them. But could
Yeah,
you
that's
have
something that hadn't even occurred to me until now, of course.
Exactly. So that's an example of a redundant system, but I think we can create redundancy in all these other ways. And something that's interesting, kind of a counterpoint to people who say that voice agents will never be reliable enough, they're inherently non-deterministic and very hard to kind of corral into doing a task reliably right. I think we've seen in infrastructure this not be the case, because servers are inherently very unreliable, and they yet were able to create infrastructure on cloud, on all sorts of unreliable systems at many, many layers that theoretically should all compound into a massive error percentage. We've seen create six nines of reliability for those systems. And that's through redundancy, that's through fallback mechanisms, that's through all sorts of other engineering techniques. And so I think we're going to see the same thing happen with agents, where you can create reliability out of unreliable systems.
Classic Luddite thing. This will never be possible. And then I can point you in the direction, Luddite, of Waymos. It's the kind of thing people say, oh yeah, it's the same thing as nuclear fusion. It's like self-driving cars are kind of always 20 years away, have been for decades, but now it's happening. And it's the same kind of thing with this, with voice agents, with more and more kind of agentic systems. The server example that you gave was beautiful because yeah, six nines of reliability, that is possible with agentic systems as LLMs themselves get better at not hallucinating on an individual call, but then also as these kinds of redundancies are built in, like you've been discussing. And so it is it is inevitable. It is not impossible. It is inevitable. This is what is going to happen. And if you don't think agents are going to be able to handle a huge swath of complex tasks in the coming years, you're wrong.
You heard it here first.
Yeah, yeah, yeah. It's not even like a risky thing for me to say that. That is what's happening. Just as there are going to be self-driving cars in more and more cities from more and more providers handling a broader range of tasks. It's going to happen. So, yeah.
I think there's an interesting parallel there of how some agents acting reliably can actually raise the tide for everyone. Where if you have lots of good examples of agents being deployed in enterprises successfully, that's going to create an environment where more agents are able to take on larger and larger tasks. And I think we saw this with self-driving, where as you're able to carefully, safely scale out self-driving, it doesn't matter which company does it, that's going to make it a more favorable environment for any company to be able to develop self-driving. Um, and so I think something we want to do at Coval is also giving companies the tools to be able to show to their customers that this is an agent that is going to perform reliably, and you can trust that this is performing not just on the demo cases that I showed you, and that maybe smoke and mirrors, but is actually working for all of the cases that you're interested in. And then you can go and explore those cases and have confidence that the agent will be behaving as you expect, and then monitor that over time. And so something Coval wants to do is we want to be able to power enterprises to be able to understand how their agents are behaving in a world where these systems are so much more complex than just knowing if your web app that you use for accounting works. You just log in and it's working or it's not working. But with agents, there's just so much less visibility, and I think that makes people inherently distrustful of the systems, even if they can produce so much value and the technology is already there.